Yes, the double decimal point, 4.5.5. What do you think it's in between? 4.5, 4.6, okay? We would not normally do it in this order, but I figure a bunch of you are leaving, a bunch of people missed period 5. We'll go out of order. We'll go back into 4.5 tomorrow, so we'll backtrack, but it works. Okay, I thought about doing 4.5, but we'll keep it here. I don't want to get any emails. I'll ignore them. Okay, it says it on there. I'm telling you now. I believe if you look at the top, it says it's graded on accuracy. It is not. You want to get them right because you learned all this already, but it is a standard homework assignment in terms of as long as everything looks pretty good, you'll get the 2 points. Okay? So please nobody email me asking because I'm going to ignore it because I'm telling you right now. Okay, so it should be all right. Good news. You know everything that we are going to do today. Systems are going to come back like at the end of the week. Therefore, we're just going to do a really brief review. This assignment shouldn't be too bad. I think it's 10 questions. Okay. Cool. So open up to the notes. Okay, at the top, okay, we are looking at the different types of solutions to a system. There's actually 3 of them. Okay, and what we're going to do is just a little sketch and then notes beneath it. Okay, but there's actually 3. Okay, the first option, if we remember anything from last year, was when you have one solution. Just draw a little sketch, a decent sketch of any intersecting lines. Any intersecting lines. One solution, and all is good. Yes, it gets overlooked. I'm ready for other holiday things too, but let's not overlook Thanksgiving. Underrated. One of the more underrated holidays out there. We also had infinitely many solutions. Just draw one line. What was our last option? And graphically, what would that look like? Good. It's a little sketch. Just a little sketch. 1, 2, 3, like right next to it. Now we had some terminology that I'm going to go ahead and guess most of you don't remember, but some of you could. Some of you have done this 3 times actually because I had you for Algebra 2. Does anybody remember what we called a system that had a solution versus one that didn't? So there's a dividing line. If it had a solution, it's like the first 2. We had a name for it versus if it didn't. Let me go forward. Moxley. Ooh, pretty good. Also, just backing up, that if it has a solution at all, it's called consistent. Okay, so I want you to jot these down wherever you can get room. Okay, if it's consistent, it has a solution. So this is consistent because there's one answer. This is consistent because there's a solution, but it's infinite, and he actually gave it to you. It's independent if there's one solution. It's dependent if there are IMS. What if there's no solution at all? Inconsistent. If you took Algebra 1 with me, and only Algebra 1, you saw that for like one day, we probably never talked about it again. If you had me for Algebra 2, we did more of it, did we not? We did. Yes. I was here. Okay, cool. So get those labels here. Now, we all remember, I'm not going to reteach it to you, graphing's not our favorite, pain in the butt, takes forever, blah, blah, blah. But this is what everything represents. We have much better ways, okay? And what methods do we have? Okay, we have ones that we're going to hit in the bottom. But what does it mean to actually solve a system? It means to find a point of intersection, which is the point that is a solution to both equations. That's what it means to solve a system. Yes, sir. That's what it means. Even without the graph, because most of the time when we do this, we're not making any graph at all. We're too cool for graphing. But it does represent that. Even if we're going to use some of our favorite methods, which I wonder if you remember our favorite methods. Okay. So if we solved this system, x plus y is 3, x minus 2y equals 0. We get to 1. That is the magical point where the lines cross, and it works for this. We're not going to graph, like at all. Because what other methods do we have? Does anybody remember them without looking at the page? Okay, at all? Sawyer? We have substitution. We also have Layla? Good times, okay? We're going to briefly recap them. You're going to be like, I remember everything, okay? And then it's going to be great, okay? Go ahead and solve that using substitution. Yes, Algebra 1 is back for today. I know. Many of you will be relieved when you're back in Algebra 2. Who's going to be relieved away from the geometry? Anybody? Put them up. Be proud. I think some of you actually prefer the geometry a little bit. It's a mixed bag. And there's a subset of you that you don't care. You'll do whatever we put in front of you. Don't forget to solve for x and y. Oh yeah. See how rusty you are? Her. How do we feel about x being negative 2? Jack feels good about it. Does anybody else feel good about x being negative 2? Does anybody want to admit to you forgot to solve for y? Oh, sadness. Where should we go to get y? Here? I mean, we could. What about here? Yeah, plug it in there. Okay, what is y? Negative 1. Okay, and again, if I had a graph, oh, I do. That's where they were crossed. So even though we're not going to make a single graph today or a single graph on your homework, you should know what these things represent. Okay, substitute it in, solve it, you're good to go. Negative 2, negative 1, that's where they would intersect. And what was our other method? Good, solve it with elimination. Oh, the good times. Actually, you did this about a year ago right now. So, somebody want to give us a brief, without doing the problem, a general description of how elimination went. Somebody just wanted to remind everybody. I should be able to pick anybody in this room, by the way. Okay, based on what I saw. I think I will, actually. I'll go with Conlon. How does elimination work? What's the idea?
It's like eliminating like each variable.
That's kind of vague. Okay. How about Sarah? How does elimination work?
You have like two variables, like you get the same amount, and then you like subtract and add to like cancel them out.
Do you cancel them all out?
No, just
One. Okay, one. So you need to scale the equations. Like right now, nothing eliminates. You need to scale them where you multiply them by something so that you either have the x matching or the y matching. Then you can add or subtract to eliminate one variable. Okay? How many of you went to eliminate x? Who went to eliminate y? Remember, it doesn't matter. Okay? So I multiplied the top by 4. I actually didn't do 5. I did negative 5 because I like to add as much as possible. And if I do, I can add, the x's go away. Negative 23, y is negative 92. It looks bad, but y is actually 4. Okay? Then you got to plug back in, get x, negative 1. Okay? Now that's not the only way to do it. I could have used subtraction, but don't goof any sign changes. And if I wanted to eliminate y, I would multiply this by 7, this by 3. Again, we're not going to relearn this stuff. You need to look at 1 or 2 questions and be like, okay, I did this a lot in Algebra 1. Okay, because the vast majority of you only need to see a couple problems in order to get this stuff done. Okay? Remember, if it's IMS, you end up with the same line. If you're solving, you end up with an identity. That's where the left side matches the right side. No solutions would represent parallel lines. Well, if you were solving, what would you end up with? A contradiction. Good. It's easy to know when they're IMS when you look at a graph. It's easy to know when there's no solution when you're looking at a graph. But if you're solving, you don't have the picture. An identity just means the left side matches the right side. A contradiction means the left side can't match the right side. Okay, you go forward. Okay, lastly, just when you're working through this stuff, please never forget all of the things that you learned in pre-algebra still apply. So if you need to navigate decimals, you can definitely wipe them out. What would you multiply through by? 10, 100, or they rarely go over 1,000, like rarely. So what would you do on this one? 100. Multiply through by 100, and then this guy becomes what? 340x. Talk to me. Cool. And then that's only an equation. It's not a full system. But if you had another one, you'd be able to work with it. And for fractions, what would you multiply through by? What is it always? Well, here it's 15. Least common denominator. Good. Okay. And which could be what in this case? Cool. And then this becomes 6x minus 5y equals what? Good. Okay. Now these aren't systems. What? Okay. These aren't systems. These are reminders that, and you'll see it on your homework. If I toss decimals in there, I toss fractions in there, and people clear it up. Okay. That is like the briefest recap ever. Okay. So we're gonna play this. What time is the field trip? 8:45. We'll play it till 8:45, and then I'll close it out, and then we'll reset with the people that are still here. Okay. Jack, now you can go ahead. All right, what should we do? We don't have enough time. I actually would. If we had more time, I would give Trust No One a shot. We have 15 minutes. What? I sure do. I sure do. Little tag. Let's go.
No, I don't think you heard me.
What name would you like to tag? We should do Ellie.
Should be level 1.
Not my toy. I'm gonna be Ellie 2.0.
I know, if it wasn't in 15 minutes, I would do a big game of Trust No One. Yes, that's very nice of you. All right, I'm starting. If you're not in there, you can get in there. Come on, we gotta get going.